Hello everyone. Through this video, we are going to discuss some additional questions on fundamental principle of counting. So here goes the first question. In my last video already I have discussed regarding fundamental principle of counting. So this is the first question here. Let us check what is it. How many different numbers of 6 digits can be formed from the digits 3, 1, 7, 0, 9 and 5 when repetition of the digits is not allowed? So in this case we are to frame 6 digits numbers, means in those numbers which we are going to frame should contain 6 digits, and the numbers provided are, digits provided are 3, 1, 7, 0, 9, 5 when repetition of the digits is not allowed. Now the first and foremost thing is what? When we form 6 digit numbers, in that case 0 should never come in the first place, because if we put, suppose this is a 6 digit number, 6 places are there. Suppose we consider 1, 2, 3, 4, 5, 6. 6 places are there. If here I put 1 0, in that case ultimately these 5 terms will be considered. 0 when put in this position will not be having any value. Therefore only this remaining 5 digits will show us this number. That means the number will ultimately become a 5 digit number. This will actually contradict this particular statement that there should be 6 digits. So in this case what we are going to do, first of all we shall be doing what? We shall be writing what are the things given in the question, actually the digits, number of digits, then after what are the numbers provided, what are the digits provided for framing those 6 digit numbers. So here is the solution part. In the solution part what we have to write, given digits are 3, 1, 7, 0, 9 and 5. Therefore total number of digits is equal to, what I am going to write here, 1, 2, 3, 4, 5, 6. There are 6 digits given to us. But this, whatever I had explained just now regarding 0, we have to mention that part here. What we shall write here? But the first digit cannot be 0. Therefore after this actually I am going to construct 6 houses where I am going to put those possible number of ways. 1, 2, 3, 4, 5, 6. Yes. One more thing is given, repetition of the digits is not allowed. So this is the first place, this is second, this is the third one, this is fourth, this is the fifth one and this is the sixth one. It is very clear from this sentence that first digit cannot be 0. That means how many options left in our hand leaving behind 0? 1, 2, 3, 4, 5. There were 5 options left in our hand for filling up this position. Now the number which is used here, for the second, third, fourth, fifth and sixth, for these 5 positions any number we can put. 0 also will be included here, but only for the first place 0 should not be included, because if we put 0 here this will no more be a 6 digit number. Therefore when I put any number apart from 0 here, how many options will be left in our hand? The number which is used here, I mean the digit which is used here, cannot be repeated further. Therefore, out of these 6 digits, only 5 options left in my hand. So I have to put 5 ways here. Then after, the number which are used in first 2 places cannot be used further. So out of these 6 places, already 2 are used up. And how many will be left for this position? Of course, 4 will be left for this position. Then after, again for this part it will be 3, then after 2, then after 1. So how I shall be writing below? I shall have to write in this way. Number of ways to fill up the first place is equal to 5. Then number of ways to fill up the second place is equal to 5 again. Then the number of ways to fill up the third place is equal to 4. Then after, number of ways to fill up the fourth place is equal to 3. Then after, same case, same writing will be for fifth place. The value will be here 2. Then after, number of ways to fill up the sixth place will be equal to 1. Now, total number of possible ways. See, one thing we have to keep in our mind that in these 6 positions, none of the positions we can ignore. That means first position and second position and third and fourth and fifth and sixth. All these 6 positions we need to consider. 6 digits we have to consider. Then only it will be ultimately giving us a 6-digit number. So, what formula, what principle we have to apply here? Fundamental principle of multiplication. So by fundamental principle of multiplication, we get what? Therefore, the total number of 6-digit numbers, 6-digit numbers is equal to, I'm going to write 5 into 5 into 4 into 3 into 2 into 1. And the result comes as what? 5 5 ja 25, 25 4 ja 100, 100 into 6 it will be 600. So the answer is 600. So here is the answer of the first question. So here is question number 2. What is said here? A number lock in a suitcase has 3 wheels, each leveled with 10 digits 0 to 9. That means the number of digits getting involved here will be from 0 to 9. So in total how many digits? Of course 10 digits. If opening of the lock is a particular sequence of 3 digits with no repeats, means for opening the lock a particular sequence of digits will be needed. Means in our words we can consider this to be the password. Okay. So in that password there should not be any repetition of the digits. So how many such sequences will be possible? So without repetition of the digits, how many such sequences will be possible? That is asked here. But password can be only one. There may be lots of sequences, but out of these only one sequence will be applicable for this for unlocking this lock. Also find the unsuccessful attempts to open the lock. That means out of all the sequences, only one sequence will be applicable here for opening the lock. So, from this total number of possible sequences, we have to subtract that one. So ultimately after subtracting 1 from the total number of possible sequences, whatever result we shall be getting, that will be the answer of this second part. So let's start solving the question. Now coming to the solution part, what we shall write here. In this case, first of all, we are going to write how many numbers, how many digits are given here. So I shall write given digits are from 0 to 9. That is total number of digits is equal to 10 here. So after this, what do we have to write? The sequence is of 3 digits with no repeats. Means repetition is not allowed here. So after that, I have to make 3 boxes for filling up. So these are the 3 boxes, 3 places. This is the first one, this is the second one, this is the third one. Actually, it is already given in the question that if the opening of the lock is in a particular sequence of 3 digits, this word is to be noted here. This is of 3 digits. So these are the 3 digits here. So we know that we already are having 10 digits in our hand. So without repetition, if there is no repetition, we have in our hand 10 ways for filling up the first place, yes or no? Then the number, the digit what is used for the first place, that cannot be repeated for the second one. So out of 10, if 1 is left here, how many will be left? How many options will be left for the second one? Of course, 9 options, means 1 is already left here. Then if these 2 places are filled in with 2 digits, then how many options will be left for the third one? This will be 8 options. So in what way can we write? Ways to fill up the first place. First place is equal to 10. Then ways to fill up the second place is equal to 9. Coming to the third place, we can write here. Coming to the third place, ways to fill up the third place will be equal to 8. So after this, therefore, possible number of sequences. First we have to calculate what is the possible number of sequences. That is equal to, how can we write? 10 into 9 into 8, and the result comes as 720. Here also fundamental principle of multiplication is applied. Why so? Because in these cases we cannot ignore any one of these digits, this place and this place and this place. So combining these 3, we are getting this result. So since there is and, therefore fundamental principle of multiplication is used here. Now for getting the main answer, means out of these possible sequences, for password only one sequence is possible, yes or no? So that's why we are going to write among all these possible sequences. Suppose 720, this is the possible number of sequences. 720 numbers of passwords we cannot have, yes or no? There is only one password, only one sequence possible here. That is why that 1 we have to subtract from total number of sequences, and that the remaining will be the total number of unsuccessful sequences. So it will be among all the possible sequences, only one sequence will be successful. Therefore, total number of unsuccessful sequences is equal to, from this total number of sequences, I mean 720, you need to subtract that one password, one sequence which is possible for unlocking this lock. That will be equal to 719, and here is the answer. Now coming to question number 3. So here goes question number 3. Let's see what it says. A customer forgets a 4-digit code for an ATM in a bank. However, he remembers that the code consists of 3, 5, 6 and 9. Actually, he remembers that in his 4-digit code there are these 4 digits, 3, 5, 6 and 9. But the arrangement, in what way the arrangement was there, he forgot it. Find the largest possible number of trials necessary to obtain the correct code. As the man doesn't remember the 4-digit code for his ATM, there is only one way out to find out the correct code, by making trials of all these 4 digits. Actually, in what way, in how many arrangements these 4 digits can be arranged, that has to be found out. Out of all those possible arrangements, only one possible arrangement will be applicable for this ATM code. Now in our hand, what we can do is, we have to find out the total number of possible trials. So here in this case, I am going to write in the solution part. What can we write? Given digits are as remembered by the customer is equal to, you cannot write is equal to, just write R. 3, 5, 6 and 9. Therefore, and we want one more thing we need to consider here, that is what? Repetition is not possible here. The digits are always distinct, and the digits are distinct. So what we shall write next? Total number of digits. Total number of digits is equal to 1, 2, 3 and 4. So after that, we have to make a table. I mean 4 places we have to make like this, so that we can fill up the box. How many options are there in our hand? In total, there are 4 options. So in the first place, we can put the value 4, because 4 options are there, by what we can fill up this place. Okay. Since the digits cannot be repeated in case of ATM pins, therefore For the second position, for the second place, how many options are left in our hand for filling up this? After using one digit here, only 3 options are left in our hand for filling up the second place. Then for the third place, for filling up the third place, how many options are left? 2 options are already used for these first 2 positions. So how many options left? 2 options are left. Similarly, for the fourth place, in place of the fourth digit, how many options do we have left in our hand? Only 1 option, because already we had used 3 options here in first 3 positions. Only 1 option is left in our hand for filling up the fourth one. So after this, what can we write? Number of ways of selecting first digit. Selecting first digit is equal to 4. Then number of ways of selecting second digit is equal to 3. Then after, number of ways of selecting the third one is equal to 2. Then after, number of ways of selecting the fourth one is equal to, what can we write here? 1. So total number of possible ways, that means total number of possible sequences, what do we have to find out? Find the largest possible number of trials necessary to obtain the correct code. So largest possible number of trials, how can we write? We cannot ignore any one of these 4 positions. That is why fundamental principle of multiplication will be applicable here. So next we can write, therefore the total number of possible trials is equal to 4 into 3 into 2 into 1. The result comes as 24, and this is the answer. And here goes the first question. In how many ways can 4 prizes be distributed among 5 students when actually number of students is 5 and number of prizes is 4? So first question is what? No student get more than 1 prize. That means repetition is not allowed here. If one student is getting 1 prize, he or she cannot get more than 1 prize. Only one he or she can collect. So after this, in the first part, actually first we shall be writing what are the things given. Let us forget about the remaining 2 questions now. First question we should concentrate. So what is given? Given number of prizes is equal to 4 and number of students is equal to 5. Here in this case, the first and foremost thing that we have to keep in our mind is what? No student can get more than 1 prize. That is the first question. Here, no student gets more than 1 prize. That is, repetition is not allowed. Repetition is not allowed. So after this, what can we do? We have to frame one table like with in earlier cases. So here goes the table. How many blocks we have to make here? There are 4 places. Actually 4 prizes are there. So first place is for the first prize, second one for second prize, third prize, then fourth prize. This is the first one, this is the second one, then third, then fourth. When repetition is not allowed, in the first case, for the first prize, we can choose any one of these 5 students. Means for the first prize, actually we can give the first prize to any one of these 5 students. Means we have 5 options in our hand, yes or no. So I can put here 5. Since the first prize is already taken away by one student, therefore how many students are left to take the second prize? Of course, there are 4 students left. Then for taking away the third prize, how many students are left? 2 have already got the prizes. How many students are left in our how many students do we have with us now for taking away the third prize? 3 options are left. And for taking away the fourth prize, how many students will be left now? 1, 1, 1. Already 3 students have already taken away the first, second and third prizes. So for taking away the fourth prize, we have 2 students with us. So in this case, what we shall be writing? Number of ways to give away the first prize. To give away the first prize is equal to 5. Then after, number of ways to give away the second prize is equal to 4. Then number of ways to give away the third prize, how many are there? 3 are there. Then number of ways to give away the fourth prize is equal to 2. So by fundamental, none of the prizes we can ignore. Therefore by fundamental principle of multiplication, therefore by fundamental principle of counting, actually multiplication comes under counting only, counting total number of possible ways, total number of possible ways will be equal to, just we have to multiply all these figures, 5 into 4 into 3 into 2, and our answer will be 120, or we can write this as 5 factorial also, because 5 into 4 into 3 into 2 into 1, if we want, we can add into one part also here, and this will give us back 5 factorial. Now coming to the second question, let us check what the second question says. The second question is what? A student may get any number of prizes. A student may get any number of prizes. That means any student can get any number of prizes. That means what? Here in this case, repetition is allowed. Therefore, for the first place also there are 5 options. If a student is taking over the first prize, he can take away the second prize also. He may take away the third prize also. So all these 4 houses will be filled in 5, 5, 5 and 5 ways. So in what way? A student may get any number of prizes, means he can attain first prize also, second prize also, third prize also, fourth prize also. So here in this case, what can we write? For the second one, given that the student may get any number of prizes, any number of prizes, that is repetition. Repetition is allowed. Repetition is allowed. So how can we fill up the boxes? This is the way. This is for first prize, this is for second, this is for third, and this is for fourth one. So since repetition is allowed for taking away the first prize, we are having 5 options. Then one who takes away the first prize, he or she can take away the second prize also. Repetition is allowed, that is why this place can also be filled in 5 ways. Similarly, the students who have taken away first and second prizes may also take away the third prize. So again 5 options, here also 5 options. So by fundamental principle of multiplication, total number of possible ways will be total number of possible ways will be equal to 5 into 5 into 5 into 5. So in total 625 ways. Similarly, for the third one, what is said here? Let us check once. The third question is, no student gets all the prizes. No student gets all the prizes. That means there is no such student who is getting all the prizes. How to calculate this? So for calculating this one, what do we have to do? Total number of ways in which a student gets any number of prizes, means the number of ways from the second value, total number of possible ways in which a student may get any number of prizes. From that we have to subtract that value in which we can get a total number of ways in which a student receives all the prizes. How many such options will be there in which a student can get all the prizes? There is only one such option, yes or no? When a student gets all the prizes, only one such student can be there, yes or no? So this can be any one of these 5. Am I right? Any one of these 5 means any student can get all the 4 prizes. So there are 5 possible ways. So for getting the third answer, what can we write? We know that total number of ways in which a student gets any number of prizes, is equal to 625. This is the value which we have derived just now. Then the next one is what? Total number of ways in which a student receives all the prizes. A student receives all the prizes. How many such possible options are there to receive all the prizes? 4 prizes are there and we have 5 students in our hand. So these 4 prizes can be taken away by any one of these students, yes or no? So he can be the first student also, second one also, third one also, fourth or fifth one also. So in this case, how many possible options are there for arranging the students, for choosing the students? There are 5 options are there. That is why there are 5 possible ways in which a student can take away all the 4 prizes. Now we need to find out the value in which the total number of students gets all the prizes. Total number of students who gets all the prizes means there are 5 options. We need to find out the number of possible ways in which no student gets all the prizes. To find out the number of possible ways, in which no student gets all the prizes. Means in this case there should not be any one student who gets all the prizes, because there are only five possible ways in which a student can receive all the prizes. So this value, all the prizes, number of possible ways in which a student receives all the prizes, that is 5. If we subtract this number from this total number of possible ways in which a student get any number of prizes, means a student can get 1 prize also, 2 prize also, 3 prizes also, 4 prizes also, means total value is this one. From this, if we subtract this number of ways, means in which a student gets all the prizes, then we can evaluate number of possible ways in which no student can get all the prizes. Means we have to keep away this term, and the rest we need to consider. Means from this total we have to subtract these 5 ways in which the student receives all the prizes. Then we can evaluate those possible ways in which none of the students are receiving all the prizes. Only 5 students can receive all the prizes, yes or no? So 5 options are there. So from 6 to 25 we need to subtract this 5, and this results into 620. So in our hand there are 620 possible ways in which a student can get, none of the students can get all the 5 prizes, all the 4 prizes. This is the answer. So here we discussed a few extra questions on fundamental principle of counting. Thank you.